Hello and welcome back to the DIY hosting of a WordPress website video series. In the last video, we got a WordPress website running in a Docker container on our Raspberry Pi, and we poked it through our NAT firewall on port 80 out to the internet, so that when we went to our browser and typed in our public IP address, we were able to show the WordPress language selection screen. If we'd continued through the WordPress settings, at this point, we would have got to a page that would have asked us for a SQL database connection. Now, we don't have a SQL database running currently, and WordPress can't work without one. So in this video, we're going to look at setting up a SQL database for our WordPress container. So WordPress requires a SQL database. In part, this is because it's a CMS, or content management system. It requires a database because the website itself, including the page content, but also the administration details for the users, are stored in a database. So when we set up WordPress, it will always require a SQL database to be running alongside. Now, on a bare metal installation, we would install WordPress on the Raspberry Pi on bare metal, which means outside of a container, and we'd also install a SQL database, again running directly on the Pi. But in our case, we're using Docker containers. So we have a WordPress container, and therefore we also need to have a SQL container. Fortunately for us, there is a SQL image. In fact, there are a number of SQL images on the Docker registry. We're actually going to be using 2 of those images, and the reason why we're going to be using 2 will be talked about at the end of this slide. Now, when we've got the SQL Docker container working, and we've got our WordPress Docker container working, these 2 containers will need to talk to each other so that WordPress can see the SQL database and store its data in there. To do that, Docker provides us with a system called networks, and it means that we can let one Docker container see another Docker container using the container name as an alias for its IP address within the Docker network address space. And we'll see what that looks like when we get to the practical part of this video. But the point is, we're going to be using Docker networks to allow the containers to talk to each other. Now, the other problem is that Docker data aren't persistent. So if we were to create our website, once we've got our SQL database container working, and we were then to close it down for the day and come back to it the next day, we would find that all of our data in the database is lost. And because this is a CMS, we would have lost the actual content of the website itself and any admin users and such settings we may have set up for our website. We would lose all of it as soon as we close down the container. So we can solve this by using Docker volumes. A Docker volume is a place on your hard drive that will store some data, and you can define what data to store in that location. And that means that when we close down the container and we start it up again, Docker will find that volume, know it already exists, and be able to use it again. Now, there's an elephant in the room. And anybody who's watching this who knows something about Raspberry Pis are probably wondering when this is going to come up. And this is that the Raspberry Pi uses the ARM architecture because the processor on a Raspberry Pi is made by ARM. Whereas for most computers, you will have an Intel processor. The difference between these 2 architectures does present a small problem. It means that we might have an issue when we install a Docker image on the Raspberry Pi because the image might not have been built for ARM. Now, often, the people who develop the Docker images and upload them onto the Docker registry do build for multiple architectures, but not always. And in the case of SQL, last time I used it, the SQL image is not built for the ARM architecture. So the reason this is an elephant in the room is that we have to use a different SQL image to use SQL on our Raspberry Pi from a different Docker image from the official one. It's still from the Docker registry though, so our problem isn't any more difficult, but we just have to be aware of this. So when we're developing on our local computer, we need to use the official SQL image, and when we put the container onto the Raspberry Pi, we need to use this other SQL image, which I will talk about in the practical part of this video. Now, some of you might be thinking, this is a bit of a problem. Docker is all about portability, and it is. Well, just to be clear, 9 times out of 10, when you transfer your Docker containers to another system, it will work fine, at least 9 times out of 10. It's only when you've got an architecture difference, like we do between an Intel computer and a Raspberry Pi, that this becomes an issue. And it does make doing a Docker container-based system a little more challenging on a Raspberry Pi, but it is completely solvable, and we're going to show how in this video. So let's head over to the desktop, where we'll be creating our SQL Docker container, and then in the preceding video, we'll be looking at setting up the network so the two containers can talk to each other, and we'll be setting up the Docker volume for data persistence on the database. Okay, so here we are on my desktop, and I have two windows open. I have my PowerShell on the left-hand side, and I have Visual Studio Code on the right-hand side. If you've followed this course, you won't be surprised to hear that I'm using an SSH tunnel with my Visual Studio Code instance, and I'm connecting directly to my Raspberry Pi so that the files I'm looking at here and the code I'm looking at here are code and files that are sitting on the Raspberry Pi. So if on the left we use my alias to SSH into the Pi, and we navigate to the website directory where we're going to be storing our website, if I use ls, we'll see the two files that I'm talking about that we created in the previous video. So this particular video is going to be all about just getting the SQL container included into the Docker Compose file. So the first thing we're going to do is we're going to create a new folder, and we're going to call it DB for database. And then within that folder, I'm going to create a file, and it's going to be a Docker file. The reason for doing this is partly because you can't have the same file name twice in one directory. Now, we can call the Docker file something else and refer to it by a different name, but I prefer to keep them as Dockerfile. It then makes it very clear what it is. And the only way, therefore, to have additional containers which have different Docker files is to have them in different folders. So this is quite a common pattern. So in the database folder, I've got a Docker file, and this Docker file is going to be the Docker file for our SQL database. So because I'm doing this on the Raspberry Pi, for my Docker file, I'm going to type in from Hypriot / Raspberry Pi -mysql : latest. This is because this particular image from this user is built for the ARM architecture. If I was to do this on an Intel platform, I would type in from, and it would be a lot simpler. It would be the official MySQL image, MySQL : 5.5, where I've used 5.5 as the version because that is the same version as is used here in this image, the top one. But for now, I'm going to stick with the ARM safe version of MySQL. So now we've got the MySQL Docker file complete. In this case, it's all we need to do is add this line. Now, Docker files are often a lot more complicated than this and can have many, many lines. But in our case, we're doing most of our configuration and setup in our Docker Compose file, so our Docker files can be quite streamlined. So now that we've done this, we're going to need to call this Docker file from the Docker Compose file. So we're going to go back to the Docker Compose file, and we're going to create a new service. The service is going to be called DB for database, : and then we're going to have to let Docker Compose know where to find the Docker file. So we type in build : and this time, instead of just a period to represent the current directory, we're going to say current directory / DB. That way, Docker is going to know where to find the other Docker file for this service. Next, we're going to include a name for the container. Excuse me. This is quite important because we'll be referencing the name wherever we use this container elsewhere. It's also the name that other containers like WordPress will use or can use to reference it. as I mentioned before, an IP address isn't a good reference for a Docker container. It can change. So instead we have this container name, which is consistent and can be used to refer to the other container. And we'll see an example of where this happens shortly. After the container name, we define the ports. This is very similar to the WordPress example beneath, but for a SQL database, the default port is 3306. So we want to map the container address space to the Raspberry Pi address space. And in both cases, we want 3306 because WordPress is going to expect the SQL database to be on port 3306. Okay, the next thing to do for a SQL database is to create some environment variables. This is part of a configuration which is quite common with Docker files and Docker Compose. When you download an image from the Docker registry, it's always a good idea to read the documentation because it will tell you how to configure the container, how you wish to use it. And in the case of a SQL container, we have to set the root password, the database name, the username, and the user's SQL password. And the best way to do it is to provide environment variables. So we provide environment variables by typing in environment, colon, and then we'll add them here. So we type in MySQL underscore root underscore password, colon, and then we need a password. I'll just say a very complicated password for fun. Then we go with MySQL underscore database. Excuse me, can't type. This has to be called WordPress. Then MySQL user. This is best to also be called WordPress. And then MySQL underscore password. Again, you can pick what you like. I'm just going to pick a very complicated password. Okay, so to be clear, these environment variables have to look as they do, at least the left-hand part of them does. This is what the container is expecting to be set on the inside. And that's it. That's all we need to do for now. That is our database container ready to go. Now we haven't talked about networks, which means our WordPress container won't be able to talk to our database container. And we haven't talked about persistence, which means when we shut down these containers, we will lose the data. But this configuration is what we need. It is the minimum amount that is required. So in the next video, we're going to look at adding the volumes and the networks so that the containers can talk to each other and so that we don't lose our database data once the containers are shut down. I hope you found this video useful. Please do like it if you did, and please do subscribe to my video course. You'll then be made aware of new videos as they become available. I'll be doing more courses on Raspberry Pi coding in the future after I've completed this hosting a website and email server course. So thank you very much, and I will see you in the next video.